Alright, let me guess. You slap a color ramp on some metal, crank up the spec and call it heat treated? Yeah, that's not it, mate. This effect is everywhere in automotive renders, product shots, VFX, but almost nobody gets it right. So today I'm breaking down the real thing. How heat actually affects metal and how to replicate it in Maya and Arnold like a pro. Welcome back to Primal VFX, I'm your host Skart. If you are into brutally realistic shaders, cinematic renders and CG done right, smash the like button, subscribe for more awesomeness. And let's dive in right now!
Alright, so the very first thing you need if you want to create a killer heat-treated metal shader is not the shader. It's a badass model. Because I don't care how good your shading skills are. If the geometry sucks, the result will suck. Period. So for this demo, I'm using this exhaust muffler. And just look at it. Beautiful shapes, clean bevels, nice transitions, interesting curvature. It already feels premium before we even touch a shader. Now check the topology. Quads only. No messy triangles everywhere. No ugly poles in visible areas. The edge flow actually makes sense. If we open the outliner, you can see it's neat, organized, readable. No random names, everything named properly. Clean hierarchy. That's not just aesthetic, that's pipeline discipline. Your lighting artist, your look dev artist, they will thank you, or they will silently hate you if your scene is a mess. So build this habit early, because realism doesn't start in the shader. Now that we've got a solid asset, it's time to make it look cinematic. Next, we're building the look in minutes. Let's go! Now let's light this beast. We've got our badass model, and I already prepared a clean look dev scene. Nothing crazy, just efficient. As you can see, we've got an HDRI for global reflections, a top light to define the form, a left light, a right light, and of course a backdrop to control our environment. Simple, clean, controlled. Now let's take a quick look at the camera. I set up a nice angle, something dynamic but still readable. The focal length is 50mm, basically close to human eye vision. Nothing fancy. Just solid framing that works for this kind of product style shot. Now I already separated the exhaust muffler into 3 different materials. Control is everything. Let's start with the middle section. We'll create an AI standard surface. I already have some maps prepared, base color, metalness, normal and roughness. So yes, we could manually connect everything one by one like a classic workflow. But let's not waste time. Let's automate it. I'm going to use my custom plugin, Substance to Maya. Link is in the description if you're interested. So we select the folder where the textures are located. Choose PNG. Name the shader exhaust. Click OK, and boom, shader tree created in 2 seconds. That's how we like it. Now let's assign it to the model and open the IPR. And just like that, we already have a solid looking central section. Clean, balanced, looking sweet and neat. Now let's move on to the chromey part. Create a new AI standard surface. Let's call it AI Metal. And don't forget to rename your shading group as well. Clean scene, always. Assign it to the geometry. Refresh the IPR. Alright, now we shape the material. Base color to a neutral gray, something mid-range. Base weight around 0.7. Metalness to 1. Now we're talking. Let's tweak the roughness. Start at 0.35. Too sharp. Push it to 0.55. Much better. Now it feels like brushed industrial metal, not a mirror. But right now it's too perfect. Real metal is never perfect. So let's add some surface imperfections. I'm using a light scratch 4K roughness map. Nice subtle detail. Drag and drop it into Hypershade. Create an AI range node. Connect everything into the specular roughness. Let's solo the map for a second. We need to control the scale. So we create a float constant node and rename it scale. With this single node, we'll be able to control the UV repeat across multiple textures with one value. Drag the scale node into the repeat UV input. Connect outfloat to repeat UV, U and V. Now change the value to 5. Better, but not enough. Let's push it to 10. That's more like it. Now tweak the AI range to remap the roughness values. Lower the output max to around 0.5. Subtle, controlled, realistic. And don't forget, set your roughness map to raw color space, always. Now let's add the normal map. Grab the scratch normal map and drop it into Hypershade. Create an AI normal map node. Again, make sure the color space is set to raw. Connect everything properly. Let's reuse the same scale node for repeat UV, so both maps share the exact same scaling. That keeps everything consistent. Refresh the IPR. Interesting. Let's increase the normal strength to 2. Okay, but you can see it's inverted. Classic. So just invert X and Y in the normal node. Now it behaves correctly. Much better. And just like that, we've got a solid believable base material for the chromy part of the exhaust. Cleaner reflections, subtle imperfections, controlled roughness. This is our foundation, but right now it's still just metal. In the next part, we're going to cook it. We're going to push this into real heat territory and build that tempered metal look the right way. Burnt to perfection. Let's do it! Alright, now it's time to create the good stuff, the heat-treated metal. First things first, let's quickly check the UVs of the geometry. Nothing fancy here, you just need proper UVs. Clean, usable, no overlapping madness. If you don't have UVs, this simply won't work properly. So now let's duplicate our AI metal material and create a new one. Rename it AI Metal Treated. Select the geometry and assign this new material to it. Then reconnect the normal map and the roughness network from the original metal shader. We want the exact same base material. Same reflections, same imperfections, same response, just a different behavior. Refresh the IPR. Perfect, everything is working. Now, before touching any nodes, let's quickly talk about what is heat-treated metal. It's a physical reaction. When metal is exposed to very high temperatures, the surface structure changes and it creates color shifts depending on the temperature level. Blues, purples, yellows, browns, all driven by heat intensity. You've probably seen reference charts like this before, showing temperature values and corresponding color changes. And if you look at real exhausts or metal parts, you'll see the same thing in the wild. That's what we are recreating. So how do we do it in Arnold? We use thin film interference. If you increase the thin film thickness on a metal shader, you'll notice it produces a very similar effect. You just need to find a value that works. For me, that sweet spot is around 300. You can tweak it, of course, but that's a solid range. Now, we don't want this effect everywhere. Only where the heat actually hits, the extremity of the exhaust pipe. So let's control it. Create a ramp. Rename it Gradient. We're going to drive the thin film thickness with this ramp. If you don't see the thin film thickness input in your shader, just right-click, go to Edit Custom Attributes, search for it, and enable it. I already did that, so it's visible here. Now connect the outcolor red of the ramp to the thin film thickness input. At first, nothing happens, that's normal. Let's adjust the ramp values. Try 100. You can already see something starting to appear. Now push it to 300. There we go. Now reset the ramp back to a value of 1. We're going to handle the intensity differently. Let's solo the ramp for a moment and shape it properly. We want a smooth transition where the heat fades naturally along the pipe. Now, instead of pushing crazy values inside the ramp, let's stay clean. Create an AI range node and rename it Boost. Plug the ramp into the AI range and then the AI range into the thin film thickness. Now increase the output max to 300. Much better. Now we can control everything cleanly from one place. At this stage, the effect works, but it's too clean. Real heat marks are never smooth gradients. So let's break it up. Create 2 AI noise nodes. One will be low frequency, the other high frequency. Just to visualize what we're doing, temporarily plug the low frequency noise into the base color and solo it. Now tweak it. Increase the octaves to 5. Push the distortion to around 2.4. Set the lacunarity to about 3.4. Amplitude around 0.8. Scale to 0.5 on all axes. Good. Now do the same for the high frequency noise. Octaves around 6. Scale 0.5. Distortion around 6.5. Lacunarity again around 3.4. Amplitude 0.8. Perfect. Disconnect the noise from the base color and reset the shader color back to neutral gray. Now we're going to combine everything. Create an AI layer RGBA node. Connect the gradient to layer 1 and plug the output of the layer node into the boost input. Rename layer 1 to ramp. Enable layer 2 and rename it low frequency. Enable Layer 3 and rename it High Frequency. Connect the low frequency noise to Layer 2. Connect the high frequency noise to Layer 3. Now change the blend mode of Layer 2 to Subtract. Do the same for Layer 3. You'll see the effect immediately start to break up. Now tweak the color of the low frequency noise. Make it slightly brighter so the subtraction is more subtle. Do the same for the high frequency. Go back to the final mix. Nice. Now adjust the Layer 2 mix weight to around 0.8. That's better. Let's refine it a bit more. Push the low frequency brightness slightly higher. Same for the high frequency. And now, yeah, now we're talking. The heat colors are back, but they are irregular, broken, organic. It doesn't look procedural anymore. It looks cooked. At this point, you can keep tweaking, adding variation, adjusting intensity, but this is a core setup. This is how you build a proper heat-treated metal shader. And now that the shader is dialed in, it's time to push the shot. In the next part, we are taking this render into Nuke and giving it that final cinematic punch. Let's boost it. Alright, now it's time to jump into Nuke and push this shot to a fully cinematic level. Here's the render straight out of Maya. And here's the final comp. Yeah, big difference. That's where the shot really comes alive. On the right you can see the full Nuke script. Don't worry, it looks scary, but it's actually very simple and very efficient. Let's break it down. We start with the main render, and the first thing I do is shuffle in the different AOVs. Diffuse, specular direct, specular indirect. Coat is empty, transmission is empty as well, so we ignore those. Then I remerge everything together using plus operations to rebuild the beauty path. At this point, the cool thing is that we are no longer locked into a single image. We can now control each component independently. For example, on the specular direct path, I add a color correction node to push contrast and tweak the gamma just a bit. That's where the metal really starts to pop. Then I use Cryptomatte to isolate the backdrop and apply a subtle color correction to it. Same thing on the end of the exhaust, where I slightly lower the brightness to keep it from blowing out. Once that's done, everything gets merged back together. Now comes the global grading part. Again, I use Cryptomatte to select the backdrop and apply a gentle color correction, just to separate it a bit more from the subject. Then I add a saturation node to fine-tune the overall intensity. Next is depth of field. This part is super important. I build a simple depth chain using an exposure node, an invert, a grade and a clamp. Then everything fits into a ZD focus node. I keep the depth of field very subtle. Just enough to add depth, not enough to scream CG blur. I'm also using a custom iris to get a nicer bokeh shape. After that, we move into lens effects. First, a soft vignette to darken the borders of the frame and pull the eye toward the center. Nothing heavy, just enough to guide the composition. Then a very subtle lens distortion. A lens reflection node to add a bit of grime and dirt. And chromatic aberration, extremely light. You should feel it, not see it. Now comes one of my favorite parts. Film grain. I'm using my custom Alexa grain setup to add a fine cinematic grain over the entire image. This step alone does a lot to glue everything together and kill that overly clean CG look. Next, the color look. I apply a color lookup node to push cooler tones into the shadows and warmer tones into the highlights. Then a LUT on top to give the image a more cinematic response. Everything here is very subtle, no Instagram filters. To finish it off, I add a glow that behaves more like a bloom. Just enough to soften the highlights and add a bit of energy to the metal. And finally, I use my multi-output setup to export 4K images, even from the non-commercial version of Nuke. If you're interested in that trick, I already covered it in another video, so feel free to check it out after this one. And this is the final result. Now you know how to build a proper heat-treated metal shader, and how to push it to a cinematic level with Nuke. So what do you think? Let me know in the comments, did you like this effect, and are you going to try it in your own renders?
Thank you so much for watching. If you enjoyed the content, you know what to do. Subscribe to my channel for more awesomeness. And I see you guys in the next video.